Thank you very much. You know, there's good things and bad things to be the last speaker. The good thing is you can build upon what you've already heard. The bad thing is I'm standing between you and lunch. So I'll try to make it as interesting as possible. Nonetheless, so what I'm going to do is I'm going to share with you a little bit what our considerations were in terms of the problems that we wanted to solve when we started GROPYUS, and then talk about how we do it. And you will see quite a few, I would say, similarities and parallels to what Professor Menges has just showed. So we've started out in creating sustainable living for everyone as the thing that we want to achieve. And we use technology for solving that issue. Now, I think this you all know, right? Climate crisis was for us really the motivational starting point. If we don't act, the world is having a problem. 38% of CO2 is actually coming from construction. So construction is 4.5 times of what individual transportation emits in CO2. So we are talking always about, leave your cars at home, but we are forgetting about construction actually being one of the main drivers. One of the reasons is because construction hasn't changed. Yeah? So if we look at the picture on the left, you would think that this is 100 years ago, but this is 2019. So it hasn't changed. Yeah? Other industries have. One of the reasons for that is because construction does not use software and data. So if you compare manufacturing, and I would consider actually exhibitors at LIGNA really part of the manufacturing sphere more than the construction sphere, though you produce components that actually go into construction. But construction doesn't use data, it doesn't use software. And it doesn't use any robotics and hardware either. Only 0.3% of robots that have been shipped actually went into construction. The rest went into all other places. And construction doesn't do R&D. If you look at service sector, only 1% of the relative share of value creation by those sectors, construction actually spends on R&D and development and on innovation. We already talked about productivity, and obviously this is the result of all the things. Yeah? If you don't invest in technology, if you don't invest in data, if you don't invest in automation, your productivity won't go up. Yeah? It will go down if you compare it to other industries. And at the same time, we have seen over the last years a 20% decrease in available skilled labor, which is 3% a year, right? So it's not just that you have less productive labor, but you're at the same time having a fewer absolute number of people available as well. That I find interesting. So if you look at Germany here, and if you look at the estimated ratio of completed buildings compared to demand, everything which is not green basically says we won't achieve what we need. And that's pretty simple. Yeah? At the same time, 15% of people in cities live in cramped conditions, and this is Germany, 15%. And it's increasing. So we talked about the coalition agreement, so a backlog of 850,000 units in Germany alone. But that's, again, not a German issue. Let's look at California. It's 2.5 million in California. Right? That's really a global thing that we're looking at. So the coalition agreement says, let's build 400,000 units, part of it, or a large part of it being affordable/social housing. Let's look at a timber strategy, let's look at circularity, and do all those things to make a difference and actually deliver to society what society needs. Now, while there is a couple problems around that. First of all, if you look at costs of construction works, being it plumbing, installations, whatever it is, have increased significantly year on year over the last years. Materials as well, we already talked about materials a little bit. 50% on average, 20 to 21 on glass, for example, fiberboard being only a little bit behind. And at the same time, interest Interest rates have gone up, so your prices of materials go up. You've got the credit squeeze, yeah, so you can't finance your construction projects. So how are you going to solve that? And I'm not even talking about those external factors like war in Ukraine and COVID-19 and climate crisis and all that has actually led to that. But as a matter of fact, what you see, and this is what you read in the newspapers all the time, buildings don't get done in time. They cost more. We won't fill the housing shortage. Yeah? Well, the good thing, there's also good news in newspapers. And this is some of the things that have been written about GROPYUS in last year, because we are basically trying to address those issues as a company. And this is what we are all started out with. So a couple of words about GROPYUS before I tell you what we do and how we approach that. So we started in 2019. We bought a robotics company right away. We bought a manufacturing plant which used to manufacture glue lamp before. At the end of 19, so early 20, built our building operating system, which is basically the digital platform that operates buildings, right? So there's the physical asset, which is the building, and then the digital side, which is the operating system. Built a pilot that we finished last year, and obviously we're pretty busy doing all those 3 years to get financing on board as well, because if you spend lots of time on developing, you also spend lots of money on doing that. So far we have investors that trusted us in giving us a little bit above 200 million euros to actually work on what we do. So we grew from none to 325 as we speak, based in 4 locations, Germany and Austria mainly. So we create sustainable living for everyone. There's a few things that are important for that. So first of all is the sustainability aspect. Yeah? So when I started saying the world has a problem, yeah, I mean that, and that's one of the main drivers for us also as motivators. Living is a basic human need. Yeah? And if you see that more than 15% of Germans living in cities live in cramped conditions, we are having an issue there. And thirdly, for everyone, meaning affordability and accessibility. Yeah? There's large shares in our population that we see as, let's say, minority groups, being people who are physically impaired or have other special needs. But we are kind of looking always at the healthy adults. So I'll share with you a few principles that we follow that we believe will get us there in delivering on our promise. So first of all is looking at buildings as products. So what does products mean? It's about developing a solution for a problem focused on the needs of your clients, of your customers, and then use constant data-driven evolution to actually improve your product over time. So, as I said, you're looking at the customers, and in our case, the customers are the tenants. Yeah? So we build multi-family, multi-story buildings. Our customers, the tenants. It doesn't matter that somebody else pays for the building, but you want to develop a product that actually fits for the users. You want to be as reproductive as you can be. Yeah? So the more repetition you have, the more you can actually learn from data and permanently optimize. So, a couple examples for product companies. Yeah? So Apple would be one, acting in different verticals. So there would be computers, there would be laptops, iPhones, and so on. Same for us. A product in our world would be a multi-family residential building. That's the first one that we focus on. Could be office building, could be schools, could be anything. But that is different products, right? You could think that, yeah, it's kind of all the same, it's all buildings, yeah? But it's different user groups, it's different needs. And if you optimize for a user group, you're actually creating a separate product. So it's about creating something that is exciting for people. It's a living experience. It's something that at the end conserves resources of the planet and makes people happy. Very often in construction industry, we consider sustainability, affordability, and a high quality product as being exclusive, right? So you can have a sustainable building, but it's going to be more expensive because you will need more expensive materials. Or you can have an affordable building, but then you are always going for the cheap stuff and you are not being sustainable and you are clearly not going to be of high quality. Or you can be sustainable, or you can be aspirational, a high quality product, but then you are typically not being at the cost point where you will need to be. So the challenge that we took for us is saying, what do we need to do to actually connect those with ands instead of ors? And one of the things is, and Professor Meng has talked about that quite a bit, and I want to emphasize this point because it's so important, yeah? To look at the whole construction process really end to end. Yeah? The construction industry is extremely fragmented with like hundreds of stakeholders that you have in a typical project. The more integrated the process from initial design all the way to building operation, and this is where we take it a little bit even further after having the building installed, but running and operating the building, that makes a huge difference in terms of cost certainty, in terms of errors that happen, in terms of speed, and so on. It starts with a good set of components. Yeah, so in timber industry, we work with a kit of parts that we've developed, which is basically, if you look at Lego, yeah, that's the kit of components, like the small part in yellow and then the larger one in blue and so on and so on. So it's really like a kit of parts that all buildings are made out of. Those kit of parts can actually be combined into units, like apartments, and they can again build buildings, and the buildings again get into city quarters or whatever you want. And this is an algorithmic design process. Yeah? This is also nothing where you would have architects sitting in designing the building, but you would have building engineers and architects designing the Lego blocks. And the good part about that being a timber system or timber-based system, I showed you this graph a little bit earlier. The very, very small one down at the bottom, it actually says increase in timber costs compared to all the other materials actually is an advantage. The reason why I'm stressing that, because we always talk about prices going up and all that, but if you look a little bit closer at especially timber, yes, it has peaked. Yes, it is still on higher levels now than it was before the pandemic, but nonetheless, compared to other materials, timber is very, very competitive still, and I think that's important to state, that we are getting out, as an industry, we're getting out stronger than we got into this crisis. So, how does the configurator work? So you are basically feeding the system the plot that you want to work with. So you're saying, this is the plot XY in whatever city it is. The system knows the building codes and knows how buildings can be positioned there, and comes up with different options, yeah? How you can actually build your buildings on this site. The different colors here represent unit sizes, 1, 2, 3, 4 bedroom units. You can choose in a certain degree of architectural freedom, yeah? So it's not about being able to select everything and have like 100,000 different options, but things that are useful. The configurator doesn't just get you a 3-dimensional design, which we also don't do necessarily because we don't need it, right? Our digital chain actually creates data for machines to read, not for people to read. So the 3-dimensional model is a nice byproduct, but it's nothing that we would need in our processes. Now, and in the configurator, you're also getting the carbon footprint, you're getting the prices, you're getting your supply chains, you're getting your manufacturing, booking, scheduling, and all the things. That's part of the outcome of the configurator. Because the data from configurator is already at 100% degree of completeness. The robots that use this data don't guess, right? You tell them what they need to do where, and this is what they're going to do. So you will never have a 95% data model. You can't. It's 100% that is needed here. So all those building components are built up out of the different materials. The code is created that then feeds the robot in manufacturing. So in manufacturing, and as I said, we bought a former glulam plant in Germany at the very beginning. So what's happening there, robots built in our own robotics company basically assemble walls. This is what they do, the wall element, slab elements. It's a timber frame, lightweight system as a basis. And we're currently working on expanding that to a larger scope. So by the end of next year, we want to be able to do 250,000 square meters of gross floor area. And that's a large exercise for us. And this is also where a significant amount of our funds actually go into, to produce a fully automated manufacturing facility for building components. That includes, wires and plumbing and whatever you can put in. So the higher the integration, the better. That's our guiding principle, I would say. Now, on site, the same thing continues. There is no reason why we would not consider a construction site being part of a factory. Well, obviously, there is prefabrication and factory principles apply, but on construction, we forget about it, and our tolerances are measured in beer bottles instead of millimeters, right? There's really no reason to do that. So taking the same principles that you have in manufacturing also to the site, run the same processes. And again, feed the data model during installation. So for every component that you're installing, you want to know when you installed it, how long it took you, why different pieces took different time spans, and so on, because you want to learn and improve your product. That's happening from design all the way through to keep on learning and keep on improving the product. So that is the time lapse of our first building that we built. So the pilot, it's close to Koblenz. It's a 9-story building, which required a concrete core for fire protection reasons. The element installation, like from ground floor all the way up, and finishing, that was about 6 weeks, and then the finishing inside took another few months, and that's basically what it was. Yeah. So in our current system, which is going for building class 4, so 5 stories, we can live without the concrete core, because that really was an issue from a tolerance level, right? If you want to connect something that gets out of a factory with 1 millimeter in tolerances to something which is kind of like this, yeah, you're having an issue. You need to plan for parts being wrong, yeah, which you don't when you just look at it industrialized. Yeah, and I was mentioning the building operating system, which is really the last component. So but that's also part of our development, so the software and the hardware components, all switches, all sensors, and so on. Building operation can be from a sustainability perspective as well as from a user comfort level. You can make huge differences. And it does not come at additional cost if it's thought through already when you design the product. Sustainable real estate funds, they need their ESG reporting out of a system. Yeah? You want to help users in communicating with their facility management and vice versa. And at the end of the day, with all those components, you can basically automate whatever you need. Yeah? So if, for example, you want to use a unit for elderly housing, and you are using sensors to actually track how people move, yeah? Because you want to make sure that if somebody falls, that you can actually set an alarm so that you can go and help. That's one of the things that you can do with the system by default. Also from a maintenance perspective, for example, the switches are without batteries, without wires. So they're only powered by the push of your finger when you use the switch, the light switch. and the controller in the unit notices when the switch is broken. The tenant gets a new one by mail, takes the old one off, scans the QR code of the new one, puts it on the wall, double-click, and it's integrated in the system again. Yeah? Things like this, because maintenance of a building, 75 to 80% of total cost of a building during its life cycle actually occur during operations and not during construction phase. Yeah? That's why I'm always finding it so interesting that people talk about, let's say 50 euros per square meter on construction. Yeah, it doesn't matter. Yeah? What matters is looking at the whole life cycle of a building. For us, the interesting part is we don't just monetize as a business model on the creation of the infrastructure, which is the building, but also on the operation of the building. So, for example, selling internet access, like faster internet access, or household insurances, or charging packages for your cars and other things would also happen through the same platform. Just like others do it as well, right? So if you look at iPhones, for example, yeah, if Apple sells an iPhone, somebody else owns the asset, but Apple still runs the operating system as well as the App Store. And that's basically the same thing that we do as a business model. And that's, again, fully integrated in the whole process. And that's why it's so important to actually think end-to-end and think with the user, the tenant, in focus. So what does this have to do with technology? We are very strongly focused on serial construction and industrialization of construction. And because we standardize and because we use those Lego blocks, technology really is the key enabler. So the digital design feeding into the fully automated manufacturing, which again feeds into the fully integrated assembly on site, which again creates all the data points during the whole process to improve the product, to get better and better and better. Then have the building operating system where you still learn from user behaviors, where you learn which light switches are used, which electric outlets are used, and so on. And you can again improve the product and get your costs on. This is what at the end gets us to a scalable solution. Because spending all this money on developing a good solution and then only building one building doesn't make sense, right? So you need to build hundreds and thousands of different buildings to actually spread those costs over a large number of buildings to make that a good commercial case that makes sense. So, and when I say digitally integrated, I mean digitally integrated. Yeah? So that's all own code. So we are not kind of using a market product and then exporting it into something and then have people work on it again, importing it into something else and have somebody program the CNC machine again and so on. It is one digital model which is linked to purchasing, to everything else. So it's basically one digital backbone through the whole process. Yeah. And last but not least, on sustainability, and I think that's one of the things I said, at least also for me, and as being one of the co-founders and the one who is actually from timber industry, sustainability is very close to my heart. We see sustainability as something important to consider holistically, right? So it's not just about replacing steel or concrete with a little bit more timber. It's around accessibility and affordability. It's around the climate that a building actually affects, which it does, and the health of the users that you're having there. So we build up our own sustainability framework, which is basically having those 4 buckets. Yeah? Being accessible for people with special needs, being affordable, using the resources wisely, and so on. And that's what we do in our product. So we have photovoltaic, for example, included by default, green roofs, green facades by default, make good use of rainwater, automatically include e-mobility solutions, which is something that we simply believe needs to be done, and so on. So that's one of the last ones, and that's kind of interesting. That's what I want to explain a little bit. Because we were looking at what is already possible and what isn't. So if you take the DGNB reference building, which is basically the typical building in Germany for multifamily residential housing. On our pilot, we were 95% better on that, on our first building, right? The DGNB standard has 30 kilograms per square meter and year of CO2 emissions. With the additional measures we have already put in place, we'll actually become positive. Yeah? So it would be a CO2 positive structure. Remember at the beginning when I said 38% of global CO2 emission comes from construction? Just imagine you can actually turn this around and not just have it plus 38%, but you can actually be carbon positive. Now, if Germany would build all 400,000 units that Germany wants to build, in GROPYUS it would be 30 megatons of CO2 saved per annum. But obviously, we're not going to do all of them. But if I look forward a little bit into the future until, I think it's 2027, we will be at around 3.3 megatons that just by doing what we do is actually being saved. And the reason why I'm saying that is not because I believe we are particularly great at that. The reason why I'm saying is it is technically possible. Yeah? And it's also commercially possible if you take an approach that makes sense. And in our case, it is really around industrialization of construction. So I find it personally not really challenging in terms of the targets that we set on the political and on the policymaker side, neither in Germany nor on a European level. I think we can do much more at reasonable commercial costs if we do it right. Yeah, and to sum up, because we design buildings as evolving products and then leverage technology as much as we can, end-to-end, all the way from integrated design to building operation, this is what helps us and lets us combine sustainability, affordability, and the aspirational character of the product with ands instead of ors. Yeah, and last but not least, a couple impressions from our pilot, which is this 9-story building once it was finished. So visible timber surfaces, timber ceilings, and remember, that's affordable housing, right? That's at the price point where you say, this is 10, 11 euros or so in rent to make it commercially useful, yeah? Already the building operating system being installed there. Nice IKEA furniture, because that's what we would assume affordable housing tenants would use, right? So it's also around, let's not do a showcase that doesn't reflect reality. Let's just be true to ourselves and say, okay, how would that look like? Yeah. So besides the pilot, we have so far already built a few different mock-ups, which is basically the evolution of the product. Work on a larger project with 10 buildings in southern Germany. Yeah, and Vonovia, because Vonovia was mentioned earlier, yeah, is a lead investor in our last financing round. And despite the fact that Vonovia won't start any new construction this year, but by the time that we've actually done the design, and not on our end, but like the permitting processes, yeah, at the time we start constructing, it's going to be 2024 anyhow. But it's good to have a strong partner to actually leverage that and use the standardization aspects that you can have in working with somebody who is building at that magnitude. Well, having this said, coming to an end. Thank you very much.